everyone, my name is Kutia Hong from 5 1. Today I want to introduce my physics project, that is Electromagnetism, Art of Science. First of all, I want to introduce an interest and simple thing for you, that is homopolar motor. Homopolar motor is one of the simplest motor built to the fact that it uses direct current to power the motor in one direction. Besides, homopolar motor also don't need to use a commutator. Its setup is very easy, only need to place the magnet on the negative side pole and the current will flow from the battery and go through the copper wire. Wait for a while, copper wire will start to spin. What we need to make the homopolar motor? It's very simple. Just need to prepare a C-size battery, but you also can use a AA-size battery or a D-size battery, and a copper wire, pliers, and a neodymium magnets. First, wrap the copper wire with the sandpaper to remove the oxygen layer on the surface of the copper wire. Next, you can use a pliers to bend the copper wire into as many shapes you like. Just make sure to follow the model as shown in the figure below. The next step is place the neodymium magnet on the negative side of the battery. Then set the copper wire shape on the battery and it will start to spin. I know you'll face some problem after you try, that is the copper wire won't will spin, so here I give you some tips. First, the one end of the wire must be touching the positive terminal of the battery and the other side must be in contact with the neodymium magnet. Second, make sure your wire can be balanced properly, if not it will soon fall off as it begins to spin. Third, use the more strongest magnet to increase the rate of spinning. I suggest you to use a neodymium magnet because it is the strongest magnet in the world. So now please watching my making process. After you've done it, let's discuss about the theory that used in this homopolar motor. When a current carrying conductor that is copper wire is placed in a magnetic field, the conductor will experience a force. This force is produced by the attraction between two magnetic fields. One is the magnetic field from the electric current in the conductor and the another is the magnetic field from the permanent magnet. Two magnetic fields combine to produce a resultant magnetic field known as catapult field. The direction of the force acting on the current carrying conductor can be determined by using the Fleming left-hand rule. So look at the picture below. The yellow color line is the current direction which is flowing down and the black color line is the magnetic field. When the yellow color line starts to move down and gets into the magnetic field, a force will form and acting on the conductor. You can use your left hand, point your index finger to the direction of magnetic field, that is from north to south, and your middle finger show the direction of the current. Then your thumb will show you the direction of the force. So what's the application of homopolar in our daily life? The most common use of homopolar motors is in generators that are installed in electroplating process plants. Although the generator uses DC current and low voltage, but the current in the motors is high enough to operate the heavy machine. Besides, homopolar motors have been used in the high torque wind turbines. The mechanic of motor provide a low-cost means of converting wind into the electricity. Next, it also can use in small engine such as those in toy cars. The spinning wheels create the force which cause the magnet to spin and create a magnetic field. So we'll stop here now. Thanks for watching.